Let's practice writing equivalent ratios and rates together. In number 1, if the ratio of pencils to pens is going to be 4 to 9, the question is how many pens would there be if there were 24 pencils? We got to keep the same ratio. First, it's always a good idea to label our two types of units we have here. So we have pencils and pens. Now they tell us the ratio here is going to be 4 to 9 from pencils to pens. So we can put 4 on top and then we could put the 9 on bottom. So we have more pens than pencils. And the question said, what if there are 24 pencils? So we're going to go ahead and put that 24 up on top for this ratio. So we can put 24 on top here. And we got to figure out how many pens there would be. So we can go ahead and put an unknown there if we would like to, or just leave it blank. I'm going to use an unknown so we can just practice using variables as well here. So I'm going to put X here. That's going to represent how many pens there would be. Now, how do we get from 4 to 24? Well, through multiplication or division, we're going to multiply by 6. And if we're going to have 6 times more pencils, we need 6 times more pens. So 9 times 6 is going to be 54. So we know that X here is going to equal 54. So if we had 24 pencils, we would need to have 54 pens to keep the same ratio of 4 to 9. Here's number 2. In this problem, we know the ratio of House 1 students to House 2 students is going to be 5 to 4. The question is how many House 1 students would there be if there's 84 of these House 2 students? So just like in number 1, let's start by labeling the two things we are comparing. So we are comparing these House 1 students to the House 2 students, and we're given a specific ratio here. They say it's going to be 5 to 4, so it's going to be for every 5 students in House 1, there are going to be 4 students in House 2. Now the question does say, what if there are going to be 84 of these House 2 students? Now House 2 is on the bottom here, so let's go ahead and put 84 down here. And we need to know how many of these House 1 students there would be. Now, I'm going to use an unknown. We'll use X here just to be a little placeholder. We have to figure out 4 times what is 84. Now, of course, you can do some long division, but for this case, I'm just going to say it's going to be times 21 since that's what it would be. But if you need to pause and write that multiplication out or division out, feel free to do so. Now, if we have 21 times more House 2 kids to keep the same ratio, we need 21 times more of the House 1 kids. Now, 5 times 21, that's going to be 105. So it's going to be X is equal to 105 here, or the number of House 1 students. So in conclusion, to keep the same ratio, if there were 84 House 2 students, there must be 105 House 1 students. So let's go ahead and write a conclusion. If there were 84 of these House 2 students, there must be 105 House 1 students to keep the same ratio. Let's check out number 3. For number 3, we are being told that we have 8 packs of candy that could cost $22.24. How many packs of these candy could we buy if we had $155.68? So start by labeling, we should have a rate of cost to packs here. So what rate or ratio are we given here? We're being told that it's going to cost $22.24. That's going to be for 8 packs of this candy. So let's go ahead and figure out, they're wondering how many of these packs of candy can we buy if we have $155.68. Let's go ahead and put that on top. And we're wondering how many packs of candy we can buy. So let's call that X for now. Okay. Let's see if we are going to figure out how many times 2224 goes into 155.68. We can go ahead and do some long division. Now to figure out how many times 2224 fits into 155.68, you should go ahead and do some long division or write out some multiplication on the side. Now I'm going to tell you right now that it's going to be times 7, but if you don't know that off the top of your head, then you should definitely write that down. Okay, so if we have 7 times more money, then we should be able to buy 7 times more of these packs of candy. So 8 times 7, we're going to say that X is going to be 56. It's going to be 56 packs of candy. So keeping the same ratio, if we have $155.68, we could buy 56 packs of this candy. Here's number 4. For number 4, the statement here we have here is if we have 3.5 pounds of turkey, and that's going to cost $29.96, how much would 63 pounds of turkey then cost? So let's go ahead and start by labeling. We have a rate of cost per pound here. So initially we're being told that we have this $29.96, and that's going to be for 3.5 pounds here. So I'm just going to put 3.5 on the bottom, and they're wondering what it's going to cost if we wanted 63 pounds of this turkey. So let's put 63 on the bottom here. Okay, so we don't know how much this is going to cost, so let's go ahead and put a variable to represent that. I'm going to use X here. And we need to find out 3.5, how many times bigger is it to get to 63? Okay, so for this one, I will go ahead and write out that long division just to practice it. So let's see, if we want to know how many times 3.5 goes into 63, we should do 63 divided by 3.5. Remember, we need to move over the decimal over so that we get a whole number as our divisor. Let's put 35 on the outside, but then we have to make it 630 for the dividend inside the house there. Okay, so 35 is only going to fit into 63 one time. 1 times 35 is 35. Go ahead and subtract here. I think that's going to be 28. Let's go ahead and bring down the 0 here. So 35 into 280, I believe that's going to be 8. So 8 times 35 is 280. So we have a remainder of 0. So I believe this is 18 times more pounds of turkey. So it should cost 18 times more amount of money as well. Okay, so multiplying here, we should take this 29.96 and then multiply this by 18. So we go ahead and do that. 8 times 6 is 48. Carry the 4. 9 times 8 is 72. Plus 4 is 76. Carry the 7. 8 times 9 is 72. Plus the 7 is going to be 79. Carry the 7. Then 8 times 2 is 16. Plus the 7 is going to be 23. 1 times 6 is then 6. 1 times 9 is 9. 1 times 9 is 9 again. 1 times 2 is 2. And if we go ahead and add this all together, we have 8. That's a 12. Carry the 1. That's 19. Carry the 1. That's 13. Carry the 1. And that's 5. So I think we're looking at here that this x would equal 539.28 or 28 hundredths. So keeping the same rate, if we wanted to buy 63 pounds of turkey, it's going to cost $539.28. Here's number 5. If Tenley can go ahead and run 9 laps in 40 seconds, the question is how many laps could she then run if there were 260 seconds that go by? So let's go ahead and start by labeling our rate here. I think it makes more sense to find out how long it'll take to do 1 lap as opposed to seeing how much of a lap you can do in 1 second, because you probably can't do too much in 1 second anyway. So I think it makes a little more sense to put the laps on bottom and find out how long it'll take to do 1 of these laps. Okay, so let's see, for the amount of time here, it looks like it's going to take 40 seconds to do 9 of these laps. Let's go ahead and put 9 on bottom. And the question is, what if she's going to be running for 260 seconds? So let's put that time on top with the rest of the time. So let's put 260 on top. And we don't know how many laps it's going to be, so let's use a variable for x for the time being. Now we got to figure out 40, how many times that's going to go into 260. Now I'm not going to write the long division out for this one, but feel free to pause the video to do so. If you can do it in your head, then wonderful. I know this is going to be times 6.5, but again, if you don't, then make sure you do practice writing that out, okay? We're going to do the same thing on the bottom. So if we have 6.5 times more time, then we should, Tenley should be able to run 6.5 times more laps, again, assuming she doesn't get tired. For this 9 times 6.5, again, if you can do this in your head, great. If you can't, then you should be writing it out. I believe this x then should be equal to 58.5. So keeping that same rate of 9 laps per 40 seconds, if Tenley was given 260 seconds and she doesn't get tired at all, then we'd expect her to run 58.5 of these laps. If Haber is going to be watching 4 Netflix shows for every 15 Disney Plus shows, what if Haber is going to watch 105 of these Disney Plus shows? So it doesn't really matter which one goes on top here because it's just a ratio. So it's going to just be Netflix on top here and Disney Plus on bottom for the number of shows that he's watching. So for Netflix, it's going to be 4. I'll put 4 on top here. And then for Disney Plus, that's going to be 15. So put 15 on bottom. Now it says that what if he's going to be watching 105 Disney Plus shows? So where does that 105 go? Well, let's put it on bottom where we have the Disney Plus shows. Now we have to figure out how do we get from 15 Disney Plus shows to the 105 Disney Plus shows. Now, if you're not sure how many times 15 goes into 105, then use long division. Again, I can do this one in my head, so I'm going to go ahead and do so. I know it's 7 times more of these shows. If you need to write it down though, then feel free to do so. Let's go ahead and figure out what this unknown would be. 7 times 4 would be 28. So we can say x would equal 28 here because 4 times 7 is 28. Keeping the same ratio, if Haber were to watch 105 of these Disney Plus shows, then he would watch 28 Netflix shows. Here's number 7. For number 7, we can see here that Alicia is going to be eating 2 cookies for every 5 brownies. And so we're going to say here, if Alicia's eating 37.5 of these brownies, then how many cookies is she going to eat? So this ratio doesn't really matter which one goes on top. I think the cookies and brownies, either one would be fine, but this is how I'm going to label them. We know that Alicia is going to have 2 cookies for every 5 brownies. So I'm going to put 2 on top and 5 on bottom to keep the same unit here. And what if she's having 37.5 of these brownies? Well, make sure we put that on bottom just because we have to put brownies with the brownies. And then we have to figure out what this unknown is for the number of cookies, right? So we can do this by figuring out how many times 5 will go into 37.5. I can do this one, but I'm gonna go ahead and just write out the work just to hopefully make this a little bit more clear, and so keeping you practicing a little bit as well. So again, 37.5, we're gonna go ahead and divide this by 5. Again, if you can do this in your head, then great, don't worry about this. But if you can't, then you really gotta practice until you get a lot more comfortable. Okay, so I'm gonna go ahead and subtract, and then this is gonna be a decimal here, 5 times 5, 25, and then we get a remainder of 0. Okay, so it looks like it's gonna be 7 times, or 7.5 rather, times more brownies. So we should have 7.5 times more of these cookies. Okay, now if we take this 7.5 and multiply it by 2, again, for this one, I'll go ahead and write it out, but if you don't need to, then don't worry about it. And so this is going to be 15.0, or just 15. So this would be x equals 15. So keeping this equivalent ratio, if Alicia is going to have 37.5 brownies, then she should have 15 whole cookies. For number 8, let's see what's going on here. It looks like Zoe is going to be eating 8 bags of turtle chips every 36 seconds. If that's the case, how many of these bags of turtle chips would she eat if 76 seconds go by? Now when setting this one up, I'm going to put seconds on top and chips on bottom. I think it's going to be a little bit more useful to imagine how long it'll take to eat one of these bags, as opposed to seeing how much of a bag you can eat in 1 second, but they're both going to be okay technically for solving for this. So for the amount of seconds, it looks like we are told it's 36 seconds, and that's to eat 8 of these bags of chips. Let's put 8 on bottom. And they're saying, what if we have 76 seconds? So let's go ahead and put 76 on top where the time is, and put an X on bottom to represent the number of bags of chips that we don't know yet. So we need to figure out how 36 is going to become 76. So it's going to be multiplying by some value here, and then we can use that same value to find out how 8 is going to become X. So I'm going to go ahead and show this division here because this one isn't as nice as some of the other ones. So I would definitely expect a lot of people to maybe write this out to be extra clear and make sure that you are on the right track. So 36 is going to fit into 76 2 times, because I know 36 times 2 is 72. Now we're going to have a remainder of 4. Okay. Now I do know that if you keep on going here, it's going to end up being a repeater decimal, and that's not very nice. So we can say that this is going to be 2 and 4/36. And we can also simplify this and say this is going to be 2 and 1/9 if you turn it into the most simplified version here. Okay. So if we multiply this by 2 and 1/9, that is how we get from 36 over to 76. So we're going to use this times 2 and 1/9 as well to figure out how many bags of chips, or turtle chips, that Zoe is going to eat in 76 seconds. Okay, so we're going to have to do a little bit more work on the side here, but it's going to be 8 multiplied by this 2 and 1/9. So rewriting these as improper fractions, this is going to be 8 over 1 multiplied by 19 over 9. So not the nicest numbers here, but 8 times 19 on top is going to be 152. So it's going to be 152 over 9. And then let's see, 152, if we take that 152 and divide that by 9, I believe that's going to be going in 16 times and 8 left over. So it's going to be 16 and 8, 9. So feel free to do that long division for 152 divided by 9, but it should be a remainder of 8 afterwards. Okay, so basically that means that we're going to have x is equal to 16 and 8/9. So she's almost going to finish 17 bags of these turtle chips in 76 seconds, but not quite. So keeping that same rate that we were given, if Zoe had 76 seconds, she would almost finish 17 bags of these turtle chips. She'd finish exactly 16 and 8/9 of these bags. For number 9, if Miss Bernal listens to 9 songs for every 4 car rides, the question is what if she's listened to 51 total songs? So how many car rides has she been on during that time. So I'm going to go ahead and label our songs per car ride just like this. And then let's go ahead and put in some numbers that were given. So songs, it looks like there's going to be 9 songs. That's going to be per 4 car rides. And let's go ahead and see what else do we know. It says that there's going to be 51 of these songs. Let's go ahead and put 51 on top here. And we don't know how many rides that's going to be. It's definitely more than 4 rides though. And so we have to figure out, how does 9 become 51? It's going to multiply by some number. So 4 is going to use that same number here. Okay. Now I'm going to go ahead and show this division for this one. But again, feel free, if you could do it in your head, you can feel free not to. But if you do need to do this, then please join me. 5 times 9 is 45. Looks like the remainder is 6. So this is going to be 5 and 6/9, which is a repeater, which isn't very nice. But we can simplify this to 5 and 2/3. Okay, so looks like if we multiply this by 5 and 2/3, we do get 51. So if we multiply the bottom by 5 and 2/3, we're going to find out how many rides it will be. So looks like that's going to be a fraction. But if we're going to multiply 4 multiplied by 5 and 2/3, we can turn these into improper fractions. So it's 4 over 1 times, I think that's going to be 17/3. Okay. Unfortunately, we can't cross cancel at all. 4 times 17, that's going to be 68. 68 over 3, I think that's going to go in, let's see, 22 times. 22 gets you 66 with 2 left over, so 22 and 2/3. So I believe that Miss Bernal would go on almost 23 rides, but to be exact, it's 22 and 2/3 rides. So keeping that same rate, if Miss Bernal is going to listen to 51 songs, that means she would have gone on 22 and 2/3 of these car rides. Number 10, let's see what's going on for this one. Looks like Miss Jaeger is going to be doing 8 workout sets in the gym for every 5 workout sets that she's going to do on the track. So a little bit of strength in the gym, and as well as maybe some speed on the track. If Miss Jaeger does 54 workout sets in the gym, the question is how many workout sets would she be doing on the track here? So comparing the track workouts to the gym workouts. All right, so it doesn't really matter which one we put on top or bottom here. For the gym workouts, let's see, she does 8 workouts in the gym for every 5 that she does on the track. So I'll put 5 on bottom, 8 on top here. And then we are told that the question is what if she does 54 of these sets in the gym? So let's put 54 on top, right where we have our other gym workouts, right? So we don't know how many track workouts that's going to be right now. We know it's more, but we have to figure out 8 times what is going to be 54. So I know 8 is going to go into 54 6 times. That's 48. So that's 6 left over. 6 over 8 is the same thing as 3 over 4. So I think it's going to be times 6 and 3/4. Okay, so again, if you need to pause and go ahead and do that division, you should get 6 and 6/8, which simplifies to 6 and 3/4. And then if you want to multiply this 5 times this 6 and 3/4 to figure out how many track workouts this would be, we can turn it into proper fractions. It's 5 over 1 times, I think that's 27 over 4. We can't cross cancel here, so this is going to be 135 over 4. And this one's a little bit bigger, so I'm going to do the division here. So 135 divided by 4. I think that's going to be 3 times 4 is 12. Have a 1 and then bring a 5. I think this would be 3. That'd be 12 with a remainder of 3. So I believe this is going to be 33 and 3/4 of these track workouts. So I think X would equal 33 and 3/4 or 33.75 if you prefer to use decimals. So we had a ratio of 8 gym workouts to 5 track workouts. So if Miss Jaeger does 54 of these gym workouts at 6 3/4 or 6.75 times the amount more of these gym workouts, then she must do 6 3/4 or 6.75 times more track workouts. 5 multiplied by that 6 3/4 turns out to be 33 3/4 track workouts. So not quite 34 track workouts, but 33 3/4 of them. For number 11, if Yadi is going to be buying 9 of the same drink, so 9 of the same drink for a total cost of $21.33, the question is how many of these drinks could they buy with $54.51? So our units here are going to be cost and drink, and typically it makes sense to find the cost for one drink as opposed to finding how much of a drink you can buy with $1. So I'm going to put drinks on bottom, and it looks like Yadi is going to be buying 9 of these drinks, so put 9 on bottom, and then the cost here is going to be $21.33. And then let's see here, going to be going for $54. Let's put that on top, and 51 cents. That's going to be the cost. So if we don't have the number of drinks here, we can put that as an unknown. Now, this one's a little bit interesting because if we try to figure out 21.33 into 54.51, might not be the nicest thing here. So something that you can do is use unit rates, and that generally can help out a lot in terms of determining some of these things. So let's go ahead and take our cost for 9 drinks initially. And what we're going to do here is we're actually going to find the unit price, or find just the price of one of these drinks first, right? So if we go ahead and divide these both by 9, then we're going to find the price for one drink. If you go ahead and do that long division, then 21.33, I'm not going to write it out, but 21.33 divided by 9, that's going to equal $2.37. So I'm going to say $2.37. That's for one drink. Then I think you're going to notice here that if you were to take this 54.51, instead of dividing it by 21.33, that it would be a little bit easier to take this 54.51 and divide it by this $2.37. Okay, so if you go ahead and use this instead, let's go ahead and rewrite this, but I'm going to put this up next to this ratio because, again, these rates or ratios are all equivalent to each other. So if you now compare this 237 and see how many times it's going to fit into this 54.51, you can go ahead and divide them, or you could try multiplying by some different numbers until you find it. And just to save a little bit of time, again, I'm going to tell you it's 23. Again, it's just some multiplication and division, really, right? And so if you do 1 times 23, you're going to see that x then would equal 23. So again, a helpful strategy if you run into some trouble is that you can oftentimes just find a unit rate or unit ratio and then work from there, since you can really scale that up or down however much you need to in different scenarios. If you wanted to figure out how many times 21.33 goes into this, you could also do that too. I just think that sometimes this could be a slightly better strategy. So feel free to try that on your own or try both to see which one you like more. But in this case, I think it's smart to go ahead and find the price for one drink and then figure out how many drinks you can buy with that 54.51. Okay, let's try one more here. Number 12, in this scenario, we see that if Deacon's going to play soccer 15 times in 4 days, then how many days would go by if Deacon plays soccer 21 times? So I'm going to go ahead and label the soccer on top and the days on bottom. Feel free to flip it if you want to. Just make sure you flip all your values as well. So he's going to be playing soccer 15 times, and that's going to be in 4 days. So I'm going to put 4 on bottom, 15 on top. And then we're going to go ahead and say, well, what about if he's playing soccer 21 times? Let's go ahead and put 21 on top with the other soccer, and then put X on bottom because we don't know how many days are going to go by. Now, how is 15 becoming 21? Now, if you go ahead and figure this out, for this one, I guess I'll write it out just so you can practice here. So we have 21 divided by 15. We could use fractions if you want to. That could save you a little bit of time, but some people prefer decimals. So again, I'm trying to use a different variety here of strategies. But again, if you feel comfortable with decimals, use decimals. If you want to use fractions, use fractions. Fractions are generally pretty good, but I'm going to use, let's see, decimals here, I guess. So if we go ahead and do this, remainder is 6. For decimals, we would just add a 0 and some decimals here. So 15 into 60, that's going to be 4, and 60. All right, so looks like it's times 1.4, and if you used fractions, it should be 1 2/5. That would be the equivalent. So if you go ahead and multiply this by 1.4 as well, then 4 times 1.4, I'll just write this one down just to finish this one up. I tried to show some of these calculations for some problems, but it's a lot to write down right now, so hopefully you're writing the ones that you need to. And if it's a lot of them, that's fine. You just got to get the extra practice in so you get better. So I'm finding out that X is 5.6. And so to keep the ratio or the rate here very consistent, if he was playing 15 times soccer every 4 days, if he played 21 times, then that means that 5.6 exact days would have gone by. All right, so there you have 12 different practice problems of using our ratios and rates, and then using either multiplication or division to kind of scale up or scale down. I think I really only used division one time here, and then multiplication in number 11. I just think finding that unit price for one drink was a little bit more helpful since we had some messier decimals in that one. So Again, I didn't show calculations for every single problem. I did show detailed work, hopefully, that you were able to follow. But in terms of finding out like the numbers that we're multiplying or dividing by, that you did some long division or use some scrap paper for that. So if you could put it in on the paper, great. Hopefully, though, that you're getting a little bit better with your operations with your rational numbers like decimals and fractions. That just about wraps up this video. If you found it helpful, please consider giving it a thumbs up and sharing with a classmate or friend that might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.